This video is going to illustrate how we can use TLSA records with Handshake to complete a secure connection to websites listed on Handshake and get the green lock in the browser. First, you need to notice that my DNS resolver is set to a Handshake resolver. This is an IP address for a Handshake resolver that I run. It does all the DNS requests on my computer, and I have it whitelisted from my home IP so it doesn't get attacked. So that's my DNS resolver set up, and you can see how Handshake sites come up in the window here. And you can see that they are not secure, and that's what we're going to be talking about today. So when you go to google.com, for example, Chrome is very happy to inform you with a lock that the connection is secure, and you can see the certificate we received from the site is signed by a chain of certificates that leads to some sort of root of trust here. So when we go to a website like 3B on Handshake, it's not secure. But if we try to go to HTTPS, so the 3B domain actually has an SSL certificate, but Chrome doesn't like it because it's self-signed. And as we can see in here, the certificate is not trusted. So we need a way to verify the certificate that 3B is giving us and tell Chrome that it's okay to use. So for that, we're going to use a library called HDNS and a little script that employs the library. HDNS is a utility written by JJ that puts some simple applications together and allows us to verify TLSA records on the Handshake blockchain, as well as digging and some other stuff that isn't quite totally compatible with the existing DNS software that's out there. How we're going to use it is with this script. So first you should notice that I'm setting my HDNS resolver again to my personal Handshake resolver, and I'm including the Brontide key. Now that is important because the results from the DNS requests I send to the server need to be signed. And for HDNS to verify them, it needs to know the public key. So this is using something in DNS land called sig0. This is basically the public key of my HNS resolver, and the results I get back from the HNS resolver will be signed and verified against that key. And that's how HDNS can be secure. So what the script is going to do is, first I'm going to use the HDNS library to get the TLSA record. And now the TLSA record is not actually on the blockchain. It's provided by a name server that is authorized by records on the blockchain. So in fact, we can quickly show how that works. When I dig 3B, my Handshake resolver shows me the A record of the website. But we can also dig 443.tcp.3b and request a TLSA record. And you can see what we get here. So this is a piece of information that identifies an SSL certificate. It's been delegated by the Handshake root zone to be authoritative, and so that's how we're going to get our security. Once we have that certificate, I'm going to use the regular Node.js TLS library. Once we get the TLSA record, we use the Node.js TLS library to get the actual certificate from the host. Then we compare them here, and then we output some stuff to the console, and finally print a file to the desktop, and I'll illustrate where that comes in later. So let's try it. We're going to run this script, and I'm going to give it the hostname 3B. Okay, and we can see the output of the script is as follows. First, here's the TLSA record from the name server, and then here's the script obtained by the JavaScript TLS module, and finally the script is output to the console in PEM format, and that's just for fun. This data is also exactly what is printed to this file here on the desktop, 3b.crt. On OS X, when I double-click a certificate, it'll open in this application called Keychain Access. And here it is, 3b. And you'll notice it's not trusted. Well, we can change that. And I know that it's okay to change it because my script has verified it as an authentic certificate. So we'll go back to Keychain Access, and we'll set the trust to always. We're going to trust this always. It's going to want my password. There we go. While you're in Keychain Access, you might want to take a look at the system roots and take a look at all the certificate authorities root certificates that just come installed on your computer. And these are all, of course, trusted just when you buy the computer. Okay, so now we've got our 3B certificate installed on our computer, and we trust it. And now when we go to 3B, Chrome is very happy. Look at that. Look how happy Chrome is with this self-signed certificate. And there we go. Now we can communicate securely with this website just as if it was any other HTTPS website on the internet. But we are using Handshake.